Hi, I'm Kathy, a tutor in Spider Lab, and today we are going to talk about how to find the limits of any function. So first, limits is another way of saying what is the value of my function at some point x. So we have a function that depends on x, and here we have an example. My function is equal to x squared. And let's suppose that I want to know the value of this function when x is equal to 2. So the only thing we do is plugging that value into where the x is at. So I have the function when x is equal to 2 is equal to 2 squared, which at the same time is equal to 4. So another way of writing this is finding the limit of the function. So I want to find the limit of my function as x is approaching 2. My function is x squared. So then I have the limit as x is approaching 2 of x squared. And the next step after this is plugging the value of x into the function. So I have 2 squared is equal to 4. We have another example. We have the limit as x is approaching -1 of x cubed plus 4x squared minus 3 divided by x squared plus 5. So we have our value of x is -1, and the only thing we have to do is substitute this -1 on every x in the function. So then, after you start substituting the values, you stop writing this limit as x is approaching -1 because you're already substituting the value. So I have -1 cubed plus 4 -1 squared minus 3 over -1 squared plus 5. So we have -1 cubed, it's -1, plus 4, -1 squared is 1 positive, minus 3 over -1 squared is 1 plus 5. We add all the numbers, so we have -1 plus 4, so it's positive 3 minus 3, that's a 0 on top. And in the bottom we have 1 plus 5 is a 6, and 0 divided by 6 is just 0. So our limit as x is approaching -1 of this function, which is x cubed plus 4x squared minus 3 divided by x squared plus 5 is equal to 0. And that's the answer for this limit. Okay, so now, sometimes we plug in the values into the limits and we don't get a result. And we are going to see an example of that just in a little bit. So let's consider the following limit. We have limit as x is approaching 1 of x squared plus x minus 2 divided by x squared minus x. So the first step always in limits is plugging the value of x into every x in the function. So again, we have 1 squared plus 1 minus 2 divided by 1 squared minus 1. If we do all the operations here, we have 1 plus 1 minus 2, that's a 0 on top, and then we have 1 squared is 1 minus 1, that's another 0. So we have 0 is 0. But we don't know what is the answer to 0 is 0. So this is not an answer for a limit. So then we have to go back to our function and we have to do some tricks to it so we can find the value of the function. And in this case, what we are going to use is factorization. I think you guys should know or may learn how to factorize in college algebra on some other course before. If not, in Spider Lab we have some college algebra books that can help you to learn how to factorize. Okay, so we have the top factorize and the bottom factorize. And we can see that we have two parentheses that are exactly the same, x minus 1 and x minus 1. So this divided by this is just equal to 1. So we can get rid of it. And then our limit now is limit as x is approaching 1 of x plus 2 divided by x, since this is just 1. And then again, we follow the same step. We look for the x value, which is 1, and we plug it into every x. So I have 1 plus 2 divided by 1, and this is equal to 3 on the top and 1 on the bottom, and 3 divided by 1 is just 3. So now we have that the limit as x is approaching 1 of the function x squared plus x minus 2 divided by x squared minus x is equal to 3. And that's the answer to this limit. Another way to solve limits, okay, to solve limits that does not have an answer is to use the conjugate of the function. So let's consider the following example. So I have the limit as h is approaching 0 of the square root of 2 plus h minus the square root of 2 divided by h. So let's see what happens if we just substitute the value of h, which is 0. So we are going to get the square root of 2 plus 0 minus the square root of 2 divided by 0. And basically we got square root of 2 on the top minus the square root of 2 divided by 0, which is the same as 0 divided by 0. Again, that's not an answer for a limit. So now we are going to use the method called conjugates. So you have the square root of 2 plus h minus the square root of 2 divided by h. And what do I mean by conjugate? If you see on the top we have the square root of 2 plus h minus the square root of 2. So we are going to take the conjugate of that. So we have two terms. The first term is 2 plus h. So now here we have a negative, the square root of 2. So the conjugate means that we are going to change this sign in between those two terms to the opposite, which is a plus. And then we have the square root of 2. Now, since we are multiplying the top by this conjugate, we also have to multiply that in the denominator of the function. 2 plus h plus 1 plus the square root of 2. Sorry. And the reason why we do this is because we don't change the meaning of the function. So we have the square root of 2 plus h plus the square root of 2 divided by the square root of 2 plus h plus square root of 2. If we divide those two terms, that's just equal to 1. So the function stays the same. And now look, what we're going to do is multiplying the top and multiply the bottom. So we have the limit as h is approaching 0. And we have this term times this term. So we have the square root of 2 plus h times the square root of 2 plus h. So that's basically just the square root of 2 plus h squared. So this square cancels with this square root. And we are just left with whatever is inside of this square root. So then we have a negative sign and a positive sign. So it's negative times positive, it's just negative. We have the square root of 2 times the square root of 2, and that's just the square root of 2 square, and we also cancel the roots. And then on the denominator, you have the h times all this. You can either spread it out or just rewrite the function as a multiplication. Okay, so now let's simplify this. So you have the limit as h is approaching 0, and then here we say that this square cancels the square root, so we just have 2 plus h, and then we have minus this 2. And all that divided by all these denominators. So I have the h, I have the square root of 2 plus h plus the square root of 2. Now we have a 2 positive and a 2 negative, so they cancel each other. When we simplify that, we have the limit as h is approaching 0, and then we have h on the top, h in the denominator times all this. Again, since this is a multiplication, and on the top we can rewrite this as h times 1, and that's a multiplication 2, we can delete those h's because that's just equal to 1. So then we continue. So we have the limit as h is approaching 0. We have only a 1 on the top because we cancel those two h's. And then in the denominator we have 2 plus h plus the square root of 2. So that's all we can do to simplify this expression. So now we are going to proceed to substitute the value of h into all the h's in our function. So we have 1 over square root of 2 plus 0 plus the square root of 2. And basically the answer of the limit as h is approaching 0 of the function square root of 2 plus h minus 2 divided by h is equal to 1 divided by the square root of 2 plus the square root of 2, which is the same to 1 divided by 2 times the square root of 2. And that's the answer. And with that, we conclude our review of how to find the limits of a function. And this is specifically used in Calculus 1. If you need more help with any of your problems, you can come to the Spiral Lab and have a tutoring session with me or Irene. Thank you.